Okay, now we're going to take a look at how to do optimization. What does optimization mean? Optimization means finding the min or the maximum amount. And a lot of people think optimization is just finding the maximum, but optimization can be the minimum. For example, if you play golf, you want the minimum score. But if you play basketball, then you're going to want the maximum score. So the maximum score is optimal for basketball, but the minimum score is optimal for golf. So you could want to minimize or maximize anything. And the good news is we're going to do this all in the calculator. So if you notice this formula, this is the formula from the last word problem we did on the last set of notes with perimeter. And we want to find the maximum. So we're going to go ahead and put this in our calculator. We cannot put P in our calculator. So we're going to have to replace the P with Y. So let's remember, though, that P of X is the perimeter. Okay, so when we're looking in our calculator, Y is going to represent the perimeter. So we're going to go to the graphing calculator right now. Let's scoot this up a bit so we can see it. So we're going to go to Y equals, first I'm going to set my window back to the standard, so zoom 6. And then we're going to go Y equals, and we're going to put this equation in. So 4x plus 4 square root of 9 minus x squared. Okay, and then we're going to hit graph. Okay. Okay, so now we're looking for the maximum, and as you can see, I can't see my maximum quite yet, so I have to change my window settings. I'm going to change my Y max to be 20. Now you can see my maximum point is right there. And very interesting thing, if you remember from this problem, the domain was 0 to 3. It ended at 3, and as you can see right here, my graph ends at 3 because x can't be bigger than 3. Now, it still has the negative, but really this is the domain 0 to 3. So on this domain of 0 to 3, I'm looking for the maximum, which is the tallest point, the highest point right here. So just like where we found intersects and intercepts and zeros, we're going to go second calc, and this time the problem is asking us for the maximum. So I'm going to go second calc, and I'm going to go down here to maximum. And just like when we found the zeros, you need a left bound, you need a right bound, and hit enter past the guessed. So that gives me 2.121. So 2.121, and that's in inches because it was a circle of radius 3 inches. Now remember, this Y value represents your perimeter. So my perimeter is 16.977, I think. 16.97. I can't read that. 16.971 inches. Okay, so that's the tricky part, is to remember we substituted this Y in for perimeter, so we have to understand that that Y is perimeter. Okay, let's look at the next one. This is the distance formula from problem 1. Okay, this is the formula we came up with in problem 1. So again, we can't put D in the calculator, so we're going to replace it with Y, but we have to remember that Y is distance. And in this time, we're looking to minimize the distance. We're looking to where do we place that X value So that is the minimal distance to the point 20. So we do the exact same thing. We go y equals, and we put in the formula, so let's clear this out. The square root of x to the 6th plus x minus 2 squared. And we're going to graph it. And this time we're looking for the minimum, which is the point about right there. So we're going to go to second calc minimum and go left bound. So make sure you're to the left of the minimum. Right bound, make sure you're to the right of the minimum, and hit enter again, and I get 0.0829 or 0.829. So 0.829, and then remember the y value is the distance, so it's 1.302. So let me tell you what that means. If we go back to the original problem that we did here, let me get one that's already filled out. We said that there's a point on this graph, so this had to do with this problem that we did right here. You could see the formula, same formula. That means there's a point on this graph where x is 0.82, such that distance from that point where x is 0.82 is the smallest distance to the point 0, and this distance is 1.302. Okay, so let's go back to our notes. So the last problem is the perimeter problem. This was the open box problem. And if you remember from the open box problem, our domain was 0 to 8. Okay, our domain was 0 to 8. So what do we want to do with this volume? We want to find x that maximizes the volume. So we put this volume formula in. Again, we can't put in v of x, so just know that v equals y, which equals volume. So let's go ahead and put this one in our graphing calculator. So we're going to clear out our old function, and I'm going to scoot this up a little bit. There we go. I'm going to put y equals x, parentheses, 16 minus 2x, parentheses, squared. Okay, now comes the point where you have to know what this graph looks like. This is a cubic equation. You have an x squared here and an x, which makes an x to the third. So we know we got to see this type of shape of our graph. Watch what happens when I hit graph. I don't see it. I see it goes up, and then it turns and it comes down to make this shape here. But I'm missing the maximum. And notice this point is 8 right here, because the maximum occurs between 0 and 8, which is what we said our domain was. So I need to get this maximum turning point into my viewing window. So what I have to do is I have to go to window, and I'm going to make this y max like 300. It goes way up there. You're going to have to play with it. Oop, I didn't quite get my turning point. You need to have that turning point in your viewing window. So I'm going to go back, and I'm going to make my y max 350. And now I get that turning point in my window. I'm looking for the maximum, so I hit second calc maximum, and I go left bound, enter, right bound, enter, enter. So it says when I make x 0.667, okay, 2.667, sorry, and that was in inches, I get a maximum volume, remember your y is your volume, of 303.407. cubic inches. So what is that telling me? This was the open box problem where we cut a square out of every corner, and these squares were x by x. So this is telling me when I cut a square out of 2.66 inches, this is going to make that box a maximum volume, and the volume will be 303.407 cubic inches.